So the next example, example 6. Example 6, y equals, example 6 is y equal exponential s. Wow. So we want to differentiate this from first principle. Y is equal to exponential s. Well, looking at this, it might look very difficult. But I tell myself I will do my best. So let's start. Add increment y plus delta y equal exponential s plus delta s. Subtract y from both sides. Y will come to the other side. I have delta y is equal to exponential s plus delta s minus y. But y is exponential s. So from here, what do I have? Well, what I can see here is that exponential s is common. Don't forget, from law of indices, when they say a raised power m multiplied by a raised power n, it is a raised power m plus n. So similarly, when I have a raised power m plus n, I can write it as a raised power n multiplied by a raised power n. So that is what I can see first. So that is delta y will be equal to e raised power s multiplied by e raised power delta s minus exponential s. That is what I have. So exponential s is common. So delta y will now be e raised power s. Then I will be left with e raised power delta s minus 1. So what do I do from there? I don't know what to do. And I look up to God again and say, God, what will happen? And God said, that is very wise because you have made the right decision. Now, God showed me, I said, recall from the Maclaurin series. Do you know the Maclaurin series of exponential s? So I now look at it, okay, I have to follow God here from the Maclaurin series. Recall the Maclaurin series of s, of exponential s. Recall from the Maclaurin series of exponential s. So then I have exponential s is actually equal to 1 plus s squared over 2 factorial plus s cubed over 3 factorial plus s4 over 4 factorial, and it goes on like that. God told me that I should apply it for e raised power delta s, that I don't need it for this one. I should use for this. So I have exponential delta s will now be equal to, that means anywhere I see s, I replace with delta s. 1 plus delta s plus delta s all square over 2 factorial plus delta s all cube over 3 factorial plus delta s all 4 over 4 factorial plus, and goes on like that. That is what we call Maclaurin series. Now, God now told me, look at the brackets. You have exponential delta s minus 1. Now, bring this 1 to the other side so that you will also have exponential delta s minus 1. So, I just obeyed. Let's see what will come out of it. So I bring this one inside to obtain exponential delta s minus 1 to be equal to 1 plus, I'll bring this one in, I'll be left with delta s plus delta s all square over 2 factorial plus delta s all cube over 3 factorial, and it goes on like that. God now told me that I should put it inside this. So I have delta y, which is equal to e raised power s, open bracket, e raised power delta s minus 1. Then I should substitute. Delta y will now be e raised power s. E raised power delta s minus 1 is equal to this. I have delta s plus delta s raised power 2 over 2 factorial plus delta s raised power 3 over 3 factorial, and it goes on like that. And it goes on like that. And it goes on like that. So after that, the next thing I will do now is that divide both sides by delta s. So I'll divide both sides by delta s. I will be having delta y divided by delta s. So this one will also be e raised power s, open bracket, delta s plus delta s all squared over 2 factorial plus delta s all cubed over 3 factorial, and it goes on like that, plus all of everything divided by delta s. Of course, if you look at the bracket, look at what is in the bracket. Delta s is common throughout. Delta s is common throughout. So if I factorize delta s out, the delta s will cancel this. So that means that by the time I factorize delta s and it cancel out, I'll be having delta y over delta s. So that I will have e raised power s. Delta s, I've already cancelled it out. This one will now be 1. Since it has cancelled out, this one, it is squared before it will remain 1. Delta s over 2 factorial plus this one will now be delta s all squared over 3 factorial, and it goes on like that. So that at the end of the day, what do we have? So that at the end of the day, what do we have? At the end of the day, we are going to obtain, at the end of the day, take limit of both sides, limit as delta s goes to 0 of delta y over delta s of limit as delta s goes to 0 of e raised power s, open bracket, 1 plus delta s over 2 factorial plus delta s all squared over 3 factorial, and it goes on like that. So anywhere you see delta s equals 0, so this one will be 0, 0, and everything upward will be 0. So that this one will be the y ds is equal to, this will be e raised power s. We will be left with 1 plus 0 plus 0 plus 0, 0, and all like that. So that will just be 1. Anything times 1 is still the same thing as that thing. So the derivative, of course, I have gotten an answer, the y ds equal e raised power s. Then God now told me, can you see that I am wise? And I say, yes, thank you, Lord. Now the next one, the next example, G. Y equal ln s. Ln s. That will be the next example. The next one to do now, y equal ln s. Ln, let me first tell you what ln means. Ln, if they say ln s, it means log s base e. So that means log to base e is what we call ln. Log to base e is what we call ln. So that is a log. It's a log function. It's a logarithm function. And what does that say? That means that all the laws of logarithm, ln also satisfy it. So that is the first thing we need to put in place here. But then now, to do the derivative of this, to solve this, there are two methods. The first method I will not solve because it's similar to this first one. This one is, since y is ln s, which is log to log s base e, by the time you write it in indices form, you will see that s will be equal to e raised power y. And when s is equal to e raised power y, of course you can see, you will now solve this way. You will solve this way to obtain the way. In this case, you will now obtain ds dy, which is exactly, as you can see, s equal e raised power y is exactly our previous example. but y is s, but and s is y. So you will now, if you solve this way accordingly, you will see that you will obtain ds dy to be equal to e raised power y still. So, and at the end of the day, you will now reciprocate. This one will now be 1 over e raised power y, and e raised power y is what? S. So e raised power y is equal to s. So that means the y ds will be 1 over s. That is the first approach. But I don't want to use, since I have explained this in the last example, let's do this one naturally. Now, y plus delta y is equal to ln s plus delta s. So bring y to the other side. I have delta y is equal to s plus delta s minus ln s. So I don't know what to do. I now go back to the source and call God. God now told me that I said something at the beginning of this question, that ln is a log function, that I should use it. And I look at it, okay, log a minus log b. Log a minus log b, what does that say? This one will give me log a divided by b. Since it's log, it will be ln s plus delta s all over s. So that at the end of the day, I have delta y to be equal to ln s over s will give me 1. I will separate it, I will have x over s plus delta s over s. So delta y is equal to ln 1 plus delta s over s. So God is with me. What is the next thing I'm going to do? The next thing I'm going to do is divide both sides by delta s. God is with me. Divide both sides by delta s. Delta y over delta s. The same thing happens here. This one will be 1 over delta s ln 1 plus delta s over s. And by the special grace of God, I know that if I multiply by s over s, it does not change anything. This one will be s over s multiplied by 1 over delta s ln 1 plus delta s over s. This is delta y. So that's what we have. So this one will now be delta y over delta s. Now, why did I multiply by s over s? You will soon get to know. God is at my back. The s divided by s will give me 1. So 1 multiplied by anything is still the same thing as that. So I have not changed the question. So I will now let this s come on top of this delta s, so that I will be left with 1 over s multiplied by s over delta s ln 1 over delta s. And by the special grace of Almighty God, this s over delta s can come up, because this is a log, is ln, is a log function. 1 plus delta s all over s, then I have x over delta s. So that is what I have. That is what I have here. So that I have delta s or delta y over delta s is equal to 1 over s ln. Before God and man, I claim that delta s over s, this s over delta s, I claim before God and man that it is same as 1 over delta s over s. You can try it. If you don't believe God, try it. 1 divided by delta s over s. You will eventually see that God is truthful. God is with me. So I will have x over delta s. So this is what I'm going to obtain. So what am I trying to do? What I'm trying to do is that by the time I will take limits, I need to tell you something here. I need to tell you something here that you should note. That when you take limits, as s goes to 0, when you take limit as s goes to 0 of 1 plus s raised to power 1 over s, as s goes to 0 of 1 plus s raised to power 1 over s, the answer will give you, the answer you obtain will be e, exponential, will be exponential. So that is what I'm trying to do here. So I'll take limit as delta s goes to 0 now. I'll take limit as delta s goes to 0. So limit as delta s goes to 0 of both sides of delta y over delta s equal limit as delta s goes to 0 of 1 over s ln 1 plus delta s over s raised to power 1 over delta s over s. So by the special grace of Almighty God, this one does not have delta s, it will be 1 over s ln, all these ones is like this, 1 plus delta s over s raised to power 1 over s. The point is, what is here, if it is what is at the power 1 over s and it is s tends to 0, as delta s goes to 0, all this one too will be 0 and this denominator too will be 0. So this one too will be ln e. Don't forget I told you that ln is log function, is log to base e. So ln of e means log to base e of e, and log e base e will give me 1. So that means ln of e will give me 1, so that at the end of the day I will be left with 1 over s. So that means the y ds is equal to 1 over s. The next example, this is this is example 7. The next one, example 8. Example 8 now. Example 8 is saying y is equal to a raised to power s. Y is equal to a raised to power s. So what do we do from there? So the first thing I will do is I will add increment y plus delta y, s plus delta s. Immediately God told me that no, don't go that way. There is no way there. Don't come this way. Try another way. Before you take increment, take the limit of take the log of both sides, log to base e. Take ln of both sides, take ln of both sides. I obey God. I took the ln of both sides so that I have ln y equal ln a raised to power s. Since ln is a logarithmic function, then I have s ln a. So after this one, and I say, God, what is the next thing to do? God now told me, add increment now. So when we add increments to of both sides now, we'll have ln of y plus delta y is equal to s plus delta s ln a. God said transfer this ln to the other side. Let it remain s plus delta s. So I did the same thing. I have ln of y plus delta y. I look at it, I said before that, let me open the bracket. I have s ln a plus delta s ln a. So the next thing I will do is, you will subtract, instead of subtracting y from both sides, you subtract s. Instead of subtracting y, subtract s ln a from both sides. Since I have ln y equal s ln a, subtract minus s ln a from both sides. So by the time you subtract, instead of subtracting y, I have ln y plus delta y. After that you subtract y. Instead of subtracting y, you subtract ln y. So subtracting ln y, I have ln y plus delta y minus ln y is equal to s ln a plus delta s ln a minus ln y. I'm subtracting ln y for both sides, but ln y is equal to s ln a. So s ln a. So s ln a cancel s ln a, so that I will have, don't forget this is a logarithm function. This one will become ln y plus delta y all over y is equal to s ln a cancel s ln a. I will be left with delta s ln a. So, and I remember what God said, that I will take away this ln a. So I will take away this ln a, so that I will have 1 over ln a. This one will become ln 1 plus delta y over y is equal to delta s. So I will rewrite this well, so that this one will become delta s is equal to 1 over ln a of ln of 1 plus delta y over y. That's what we are going to have. So that at the end of the day, I will divide both sides by delta s. Since I have delta s here, divide both sides by delta y instead. So this one will now be delta s over delta y is equal to, this is still 1 over ln a multiplied by 1 over delta y. Since I divide both sides by delta y, ln of 1 plus delta y over y. That is what we are going to have. Again, what I did here, s over s, I put s over s here. Don't forget, I'm approaching this limit. This is where I'm going to, you can say I have ln of 1 plus delta s over s, 1 plus delta y over y, and I have 1 over y here. Since I have multiplied both sides by, I have multiplied both numerator and denominator by s over s, I will do the same thing here, so that I will have delta s all over delta y will now be equal to, still leave this one, 1 over ln a multiplied by y over y. You can see I have multiplied both sides by y over y multiplied by 1 over delta y ln of 1 plus delta y over y. That is what I have. So the next thing I'm going to obtain here is that I will have delta s over delta y to be equal to 1 over ln a multiplied by, let the y come here, I will be having 1 over y multiplied by y over delta y, then ln of 1 plus delta y over y. That is what I'm going to have. Now, recall from the law of logarithm. The first thing you have to recall is that from the law of logarithm, when you have 1 over log a base b, this is exactly same. What will happen is that the base will come up, what is here will come to the base. This is exactly log b base a. This is exactly log b base a. So that means this 1 over ln a. Don't forget, ln is log to base e. Log a base e. This one will be log e base a. So that means I have delta s over delta y to be equal to, this one over ln a is log what? Log e base a multiplied by 1 over y. So this one will come up to become ln of 1 plus delta y over y raised to power of y over delta y, or I write 1 over delta y over y by the grace of God. So the next thing is to take limit now. Limit as delta y goes to 0. So limit as delta y goes to 0 of delta s over delta y equal limit as delta y goes to 0 of everything here of log e base a multiplied by 1 over y ln of 1 plus delta y over y raised to power of 1 over delta y over y. This one will become, since I have delta s over delta y and delta y goes to 0, this one will become ds dy is equal to, all this one does not have dy, so it can come out. This one will become log e base a multiplied by 1 over y. Then this one will become limit as y goes to 0 of everything here will become e. So ln of e, I've told you before, is same thing as 1. This is log e base e, which is 1. So that's at the end of the day, I have delta s over delta y is equal to this is 1, this is 1, this one will now be log e base a all over y. Don't forget what I'm looking for is the y ds. I'm looking for the y ds, so that means I will reciprocate. That means that the y ds will be equal to y over log what? Log e base a. And this is the same as y multiplied by 1 over log e base a. So the y ds is equal to y is equal to a raised power s. Don't forget, y is a raised power s. So now I have a raised power s multiplied by this same law of logarithm that say 1 over log a base b is equal to log b base a. This one is also 1 over log e base a is same thing as log a base e, and log to base e is same thing as ln. Don't forget. So that means that the y ds is equal to a raised power s ln or log to base e of a. That would be the answer to that particular question. Example 9. I think this is the next one is number 9. So for 9, number 9 is tan y equal tan s. That is another member of trigonometry. So this one, y plus delta y, this one will be tan s plus delta s. Right? Bring delta y to the other side. I bring y to the other side. This one will be tan s plus delta s minus y, but y is tan s. Then you will now have to recall from addition formula. Recall that tan A minus B is equal to tan A minus tan B all over 1 plus tan A tan B. Recall that tan A minus B is equal to tan A minus tan B all over 1 plus tan A tan B. Recall that. So what will now happen from there? What will happen from there is that what? So what will happen from there? What will happen from there is, if we let us now let A be equal to s plus delta s by the inspiration of God, and B to be s only. What happened? This one will become tan s plus delta s minus s. It will be equal to what? Tan A minus tan B, which is tan s plus delta s minus tan s all over 1 plus tan A, that's s plus delta s, tan B, that's tan s. So S minus S will give me 0, so that I will be left with tan S. But at the same time, I will cross multiply. Cross multiply. 1 multiplied by this, I have tan S plus delta S minus tan S is equal to S minus S will give me 0. I will be left with tan S. So this one, tan S multiplied by this, so that will be tan delta S. Since I will be left with delta S here, multiply by all this, multiply by 1 plus tan S plus delta S tan S. That's what we are going to obtain. That's what we are going to have. So that means that tan S plus delta S minus tan S is equal to tan delta S and this. So that's what I'm going to put here. So that means delta Y is equal to tan S plus delta S minus tan S. Tan S plus delta S minus tan S is equal to all this. So I will have tan delta S open bracket 1 plus tan S plus delta S tan S. 1 plus S plus delta S tan S. Divide both sides by delta S. So I have delta Y divided by delta S. The same thing happens here as well. Tan delta S. I'll just divide this delta S here because of how the limit is going to look like. You need to know about this, that limit as S goes to 0 of tan S over S is also 1. You need to know that limit as S goes to 0 of tan S over S is also 1. So take limit of both sides as delta S goes to 0. So limit as delta S goes to 0 of delta Y over delta S is equal to limit as delta S goes to 0 of tan delta S over delta S open bracket 1 plus tan S plus delta S tan S. So this one will become the Y ds. So by the time you take limit of this one will be 1, then open bracket 1 plus, anywhere you see delta S put 0. S plus 0, S, that's tan S. Multiplied by another tan S, that's 1 plus tan square S. So 1 plus tan square, so the answer will give me 1 plus tan square S. So that means that the limit when Y is equal to tan S, the Y ds is 1 plus tan square S. But from trigonometry identity, 1 plus tan square S is exactly sec square S. So that means that the Y ds is equal to sec square S. It's equal to sec square S. So the last one, the last example is arcsin. The last example I'm going to be doing today in this lecture, example 10, is if y is equal to arcsin, sine inverse of x, and you are told to find the y ds. Well, it is very trivial because without lots of generality, just take sine of both sides, or you say s equals sine y. Take sine of both sides, then s will be equal to sine y. Then s will now be a function of y. You will now start doing s plus delta s equals sine y plus delta y and all that. So if you check, I think example from here, I think example 5. Yes, from example 5. Example 5 says that showed us that y equals sine s. In example 5, I have solved this and I obtained the y ds to be equal to cos s. So that means similarly, if I have s to be sine y, by the same example, if I'm using the same approach, I will get the s dy to be equal to cos y. But I need to get the y ds, so that means the y ds will be equal to 1 over cos y. So I want to write cos y in terms of sine y. So there is no other way than to have 1 minus sine square y. Sine square theta, recall or note. Let me write it very well so that you can understand what I'm trying to say. So we have that sine square y plus cos square y is equal to 1. If you make cos the subject of formula here, you see that cos y will be square root of 1 minus sine square y. That is from trigonometry identity. So that's what we will obtain here. So that means dy ds is equal to 1 over square root of 1 minus sine square y, which is equal to 1 over square root of 1 minus sine y. Sine y is same thing as s. Sine y is same thing as s. Sine y is s. Sine y is s. So that's why we have s squared. That's 1 minus s squared. So therefore the y ds equal 1 over square root of 1 minus s squared. You can like and subscribe to this YouTube channel for more of mathematics rigor proof or example. And if you want to be solid and to be strong in mathematics, thank you very much.